Okay, next up, we're going to go to the other side of cold-in-place recycling. Our speaker is Dan Schellhammer from Midstate's Trucking and Reclamation? Is that the official term? You have a degree from the University of Minnesota?
Yeah.
Cold-in-place recycling with Dan Schellhammer.
All right, yeah, so my name is Dan Schellhammer. I'm the Vice President of Midstate Reclamation and Trucking. We're a pavement rehabilitation contractor that does work throughout the Midwest here. So I know really pavement preservation and pavement rehabilitation are two disciplines that really match up well together. So excited to get the opportunity to talk to you guys today about cold-in-place recycling. Just a quick overview of the topics I want to cover today. Utilizing the right tool at the right time, the right place. This is really a mantra within the pavement rehabilitation space. I'm going to tell you this today. Probably a lot of you are used to doing conventional construction, conventional reconstructs. There's a technique and a technology out there that will save you money in any road condition you have going today versus what you're doing. You just have to be able to select the right tool, the right time, the right place to implement it. We're talking about cold mix and compare it to hot mix, and actually not compare. We're going to differentiate the two. All right, the two are not the same. They look similar, they're not the same. We're talking about how it's made, talk about the economics of the process, some of the additives that we incorporate to our 100% wrap mix, and then we'll go through some best practices. There's some tricks of the trade. Getting through this in about a half hour is tough. There's a wide area of things that we could discuss, but just going to try and keep plowing on through it here. So utilizing the right tool at the right time, the right place. Cold-in-place asphalt recycling is not the fix for every single road. Right? It's just not. There is a pavement rehabilitation technology available to you that's out there. But when you do make the right selection, kind of out of that tree of tools in your toolbox, you're going to save a bunch of money. All right? Have an example of that. You're going to save time versus a reconstruct. All these processes we're recycling materials in place. We're reusing what you, as an ownership group, already own. All right? When I see an old, withered, tired asphalt roadway, I don't see it as a liability like some of you folks might see it. I see it as an opportunity and an asset that you should manage, all right, and recycle and keep using. There's nothing wrong with the rock that's in that road. There's nothing wrong with the gravel that's in that road. It's millions of years old, all right? It just needs to be repurposed. That's what we're talking about here when we do cold-in-place recycling. Cold mix, it's really flexible, really pliable. It's really resistant to cracking, much more so than hot mix, all right? So if you partner cold mix and hot mix together, you're going to reduce your cracking, all right? It's really going to extend the life of your pavement. It's going to increase your service life. It's going to reset your entire maintenance cycle, all right, if you implement it properly in the right place at the right time. You reduce maintenance costs, fewer cracks, less crack sealing, all right, less water infiltration down into the subbase and subgrade. You're going to improve your ride because we're applying all this material with a modern paver, right? With a modern ski, modern electronics. We have grade controls, all those fancy tools we have now to help out with ride. We're going to improve it. And then we reduce carbon emissions and recycle and reuse. I think moving forward as engineers, this is going to be something that we're all going to have to start incorporating into our design probably in the next 5 years. All right? This process you have for rebuilding a road, how much energy are you consuming? You look at a normal reconstruct, maybe per mile. There's a study that the University of Illinois just finished up with that basically energy consumption for, just an example, from 1 lane mile to do a reconstruct today with a mill and fill or tearing that material out might take 100 megajoules of energy. Right? If you implement the right strategy, cold-in-place recycling, the right job, it'll just take 5 megajoules of energy to do that same work, right, with the same outcome. So something you should keep in mind moving forward. So cold mix, it's not hot mix. Both pictures I have up here, everybody hear me okay? I probably don't even need that, I can start barking. But so both pictures up here are of cold mix, the cold mix project. The picture on the left and the picture on the right. So the picture on the left, it looks very similar when the material is placed, when you look at it from afar, all right? It's black, it's smooth. Those are really where the similarities end, all right? Picture on the right, hopefully everybody can see that, but cold mix, it's a lot coarser than hot mix. Why is that? Well, we're utilizing 100% wrap. When that hot mix was first made, you put a bunch of fines into it, right, to keep your void spacing down. Well, we can't break the bond of that old residual oil with those fines when we go and recycle it. Still, those fines remain bound in that cold mix material, and that wrap material. So generally, our void space is going to be double that of hot mix. All right, so we're much more coarsely graded, and we're much more sensitive. All right, and I say sensitive in that cold mix is really susceptible, if you leave it out to the elements, especially here in the Midwest, where it gets cold in the winter, to water. All right, if we don't cover up cold mix with some type of surface treatment, that water's going to get in the cold mix, it's going to pop out when it freezes. After it pops out, it's going to create a pothole, and then it's going to create just a failure of the roadway system. All right, so right tool, right time, right place. It's a wonderful process, but you always have to surface it with something. All right, if you don't, you're setting yourself up for failure. So there's several ways you can make cold mix, right? The first I'm going to discuss today is with a multi-unit recycling train. All right, Midstate runs 3 of these throughout the Midwest. A multi-unit recycling train is basically built and designed for high production and really finite gradation control. All right, so the cold and press process we want to do is we want to, in a nutshell, we're going to head on down the road, and we're going to do about 2 lane miles a day. So what we're going to do, but we're going to pick the road a full lane width at a time. All right, we're going to do that with this mill right here. After that mill picks up that material at a depth of 3 to 4 inches, that wrap's going to get dumped into a crusher. All right, and any oversized material is going to get crushed. And also everything we're going to do is going to get screened, and we actually have a closed loop conveyor system on our crusher. So any oversized material gets thrown back into the crusher and crushed again until it's sized. All right, so we have really good sizing control when you use a multi-unit train. That same crusher unit, the way Midstate runs our equipment, it also has a pug mill on board. All right, so after that material's been crushed and sized, it gets conveyed up to a pug mill, the front of the machine. All right, before it hits that pug mill, it goes over a weigh bridge. Every single pound of wrap going to that pug mill gets weighed and sent to the central computer. All right, so what gets thrown in that pug mill? Well, it's just 100% wrap and some oil. And that oil gets incorporated. It's controlled by the onboard computer. All right, so there's slight adjustments that computer's making to our injection system with every single pound of wrap that goes over the belt as to how much oil that we add. All right, so it really helps get a really high-performing cold mix as you're working your way on down the road. After that stuff is mixed, it gets dumped down on the road in a windrow. And then it just gets paved like any normal paving operation, hot mix operation you'd see. That's the one similarity, is how it's placed. All right, we just, like I said, moved down the road doing about 2 lane miles a day. Really the limiting factor for us, for production, is the hardness of the road that we're recycling. The harder the road, the slower we're going to go. The more effort it takes to crush, the longer time it's going to take. So we'll have some jobs, we might just do 3/4 of a mile in a day. That's a slow, slow day. We have some days, some jobs we'll do 5 miles in a day, but 2 is about our average. So that was multi-unit train. You can also create cold mix with a single unit train. All right, but what we're going to do is we're going to take that crusher and pug mill setup out of the train. And we're going to rely on basically the technology of the drum, the mill head, to do all your sizing. All right, so you're going to lose a little bit of kind of that quality control process you have with a closed loop screening system. And you rely totally on the speed of that mill and the design of the drum and how that works to get your cold mix produced. So generally a multi-unit train, it's meant for high production work on long stretches. Single unit train works great in urban and suburban environments and on jobs that are smaller, because we don't have to mobilize as much equipment, and it'll save you some money. All right, but right tool, right time, right place. You know, kind of your performance could depend on which methodology you utilize, which train you pick, and single units and multi-units compete with each other in the marketplace all the time. They're generally interchangeable. And the third way you can make cold mixes with a cold central plant. We just completed our first job for some test cells up at Min Road for the NRRA, utilizing this process. So basically you take a multi-unit train, you pull it apart. This is our crusher pug mill sitting here. Wrap gets loaded into that crusher pug mill, and we produce a cold mix that gets put up in a pile and taken out on a job and paid relayed. All right, so a good application for this might be a city project where you have a lot of iron in the road. Mills and iron castings in the road don't work well together. All right, they destroy each other. So if you were to take that wrap, take it to a centralized location and process it this way and bring it back out, It's a great application if you have to do utility work, update your water main, whatever you have going on. So just kind of the blend of utilization of those different technologies here in the Midwest from what I see. About 75% of the work that's done in the Midwest today is with a multi-unit trade. About 24%, or actually a little bit more than 24%, is done with a single unit. And less than 1% of cold mix that's produced in the Midwest is produced with this cold central plant recycling setup. I see that ratio changing. It's going to change pretty quick here in the next 2 to 3 years. I think you're going to see a lot more wider use of the cold central plant recycling, and also probably the single unit. But I also see the volume of recycling that we're going to be doing increase as well. All right, and the market there's equipment on the sideline ready to go, ready to do your work for you if this is a technology that you want to implement. So if you look at the economics of cold-in-place recycling, there's a bunch of different scenarios we could talk about. We talk about life cycle costs, and we could really get lost in the weeds talking about that. But one example I want to just kind of show you guys today is look at the price of cold mix by the ton. And want to kind of maybe ask the group, what do you guys pay to place cold mix or hot mix by the ton? Pay relayed. Does anybody here know? I see some people are nodding, some people are looking away. They want to say? Well, okay. Nope. So from what I've seen, hot mix by the ton has generally been between $42.50 and about $68 a ton here in the Midwest. It's an average, right? Placed. I've seen it as cheap as $37 a ton on a really big project in Minnesota. I've seen it expensive as $125 a ton in rural South Dakota. It's crazy what it can go for. All right, but it's a big range. All right, if you compare that to the price that we can make cold mix for, you do that for less than $30 a ton. All right, that's recycled and placed, ready to go out the door. All right, so we are cheaper when you're looking at this scenario. You have to utilize the right tool at the right time, the right place. You can't plan on $30 a ton mix for every single job. Doesn't work that way, but when you do utilize it, it can save you a bunch of money. And Francis, he comes from Iowa, where they implement a lot of this technology. They do about 3.5 million square yards a year of cold-in-place recycling in Iowa. Very competitive market. There's actually 4 contractors competing for that work. You get a lot of work out of there. That price gets down to $18 a ton. Is what the state of Iowa is paying. It got as low as $14.83 on one job this year to do cold-in-place recycling, 4 inches of it. All right, really impactful. It can really reset your maintenance cycle and your life cycle costs, what the cost of your pavement management system is. Really impactful. So what do we have to add to this wrap, right, to make cold mix? There's one key ingredient that we need to add, and that's oil. We had 2 forms of oil that we add. It's either an emulsion that's added about 3% by weight, or it's a PG-graded binder that we foam and incorporate in the pug mill. All right, that emulsion, generally, most folks these days are using an engineered emulsion. All right, the emulsion gets modified to really prevent raveling, increase stabilities, get you better long-term performance. You just slightly modify, a base stock emulsion. We have a couple of counties that are still just using just CSS1 or high flow as well on really low volume roads, but most folks have switched over to engineered emulsion. Really good bang for your buck. The other process with foam, in that pug mill, basically we have to modify the nozzle in the pug mill. We switch them out when we go from foam to emulsion. We have to put a different nozzle on our injection system. What we do is we inject that oil at temperature about 325 degrees through the nozzle. At the same time, we add some water to that hot oil. Oil and water don't mix, never will, never have. But when that happens at temperatures, it foams up and expands. It's anywhere from 8 to 15 times its normal volume, right? It gets thrown, that foam gets thrown right in the pug mill and gets mixed thoroughly. That's what makes foam work, is you have to have the proper foaming characteristics to get it to blend properly, get uniform mixing of that material. But these are just the binder types that are used here in the Midwest today for foam. State of Iowa, they're using exclusively foam now. They switched over to that. State of Minnesota, they use pretty much exclusively engineered emulsion. I'm going to tell you this, if you're asking me what the difference between the performance of the two is, I haven't seen a big reason to go one way or the other. It's really an economic decision. How cheap can I get that oil out to a job? That's how I'd make my decision if I'm picking one or the other. Today, there's some studies that are actually going on right now to compare the two and test cells right next to each other. You check on performance, but it'll be a couple years before they report that information back out. Right now, I don't see a difference, though, from our experience. Great thing about cold mix, too, though, it's really versatile. We can modify it to enhance its performance. We can add these additives you see up there. We can add cement. We can add lime slurry. We can add rock for additional stability. All right, we can modify that cold mix to perform in pretty much any scenario that we're looking for. All right, and really that's the future of that cold mix is being able to meter and control all these different additives we're adding to it, right, and get you a good uniform blend out in the roadway. And that's where the technology is going to, right? That'll help us compete with hot mix at some point here. It's a ways away, but that's where things are going. Everybody went from hot mix to warm mix. Next iterations to go to cold mix. So some tricks of the trade. We're talking about cold in place recycling. I talked about utilizing the right tool at the right time, in the right place. We have to have jobs that are good candidates in order for it to work, or in order to realize that savings of, well, we haven't put mix out there for $30 a ton. All right, we can go the opposite way of that. If you pick the wrong job, it's just going to be a colossal failure. It's going to cost you a bunch of money. It's going to be bad. All right, that's why project selection, pre-investigation for a project it's really key to making this process work. But what would we like to see if we get to select our job? We want to see a job where the base and subgrade are structurally sound. We don't have any subgrade issues. All right, that big mill up at the front of our train weighs about 135,000 pounds. All right, if there's a soft spot in the road, that we'll find it, and it'll take a dive, and we'll have to dig it back out. We've been there, we've done that. All right, so we need a stable subgrade, and it needs to be well drained. All right, cold mix, like anything else, it can kind of act like a wick. So if your subgrade or your base is wet, it'll pull moisture up into the cold mix. And we're adding water as a compactionate to our cold mix to get it to compact. All right, so if we end up disrupting the amount of water we have in it, it'll fail. It'll rut out, right, and cause some problems. So it needs to be well drained. You see the crack pattern here. This is actually a job we did in Wisconsin, just outside of Milwaukee. Crack pattern, it's pretty bad. A lot of transverse cracking, a lot of longitudinal cracking. There's alligator cracking on this job. But the roadway was elevated, it was dry, and I don't know how, but the base had survived this asphalt failure. All right, and so it was a great cold in place candidate. Bad candidates is exact opposite, right? Kind of talked about weak subgrade, lots of moisture. Usually I get calls from our guys out in the field if they get out on a job and they say, Dan, we have cattails on both sides of the ditch. Why are we here? Right, that's a good indicator you're going to have a really soft subgrade. So those are the things we want to avoid. The other thing, we can incorporate gravel to a cold mix. It's not a big deal. We do it all the time. We do widenings. We'll dig a little deeper if we need to at times. What we need to do is really have to keep a consistent blend of wrap to gravel. All right, so our oil incorporation rate is basically kind of based on surface area. It's based on lots of things, but surface area is one of those indicators for us. So if the surface area varies because the amount of wrap to gravel is varying, we won't have our oil incorporation rate right. It's not the right job to do cold in place recycling on. It's not the right tool, not the right time, not the right place. All right, you got to know what the limitations of the process are. So generally, cold in place recycling, we're done at 3 to 4 inches of depth. That's our sweet spot. Anything less than 3 inches, and you're seeing the material's ability to resist reflective cracking go down substantially. State of Iowa has done a bunch of studies on that, accumulated a bunch of data that prove that. When you go up from 4 to 5 inches, the size of our windrow increases, all right? And you get up over 5 inches, instead of using a normal asphalt transfer device, we have to get a shuttle buggy out there, which increases cost, right? When you go up over 5 inches, we're in a zone where I'm not really sure modern paving rollers can get good uniform density and compaction of that cold mix layer. All right, so what do we have to do? We have to bring out a pad foot roller, right, to get that thing rolled out. It kind of defeats the purpose of paver laying something if you got a pad foot on it, right? So that's when if the repairs to be more than 5 inches, cold in place recycling is the way to do it. But there is a pavement rehabilitation technique, and that's SFDR, stabilized full depth reclamation. You take a reclaimer out there and inject some oil, all right? and you're on your way. It's a cheaper solution for a deeper fix. I just want to point out another limitation of cold-in-place recycling, and that's cross-slope adjustments that we can make. All right, we can make adjustments about 0.5%. Reason for that is the material we pick up with a mill, that's all we had to put back down. We're not a hot mix contractor that can bring more material out and wedge, right, to level up a roadway to get where it needs to be. If we do make corrections that are more than 0.5%, we're going to vary the thickness of our cold mix layer. You're going to have 2 inches at the center and 4 inches out here at the shoulder. Engineers, they hate that. That doesn't work well when they're calculating things, all right? Doesn't compute. So that's a limitation of the process. Does that mean you shouldn't do cold-in-place recycling? No, it doesn't. Might be more economical. There's some alternates there. You could wedge or level with hot mix after we're done to get that balance back out. You do some 3D milling, right? New technology that's coming out now. Lots of states are looking at implementing it. They've been talking to us. If you were to profile mill that roadway surface beforehand, great solution to fixing your cross slope issues. But it's tough for us if your existing roadway is at 4%, you want to get it back to 2. You're not going to get the final product that you want.
Can you add wrap prior to?
Yep, we do that all the time. The question was, can you add wrap beforehand? Yes. Yep, you definitely do that.
So you could wedge with the wrap prior to?
Definitely do that, yep. So just want to talk about traffic control for cold-in-place recycling. We prefer that roads are closed. All contractors would, right? But most of the time we're in a pilot car flagger scenario. We want to manage the time lapse of traffic on a freshly placed cold mix mat. So we want to keep traffic out of it for about 2 hours. Let it initially set up. All right, get traffic on it before that. They'll have a tendency to rut a little bit. That's something we want to avoid. So we'll actually manage our traffic control zone to keep traffic off it for 2 hours. Generally, just rule of thumb, we try and keep a work zone less than 2 miles. It's just a safety thing. Our train moves against traffic. All right, so then whenever we have traffic parked for that flagger operation, it's parked on old asphalt or, cold mix that's been cured out for a long time. All right, we want to keep park traffic off of that cold mix mat. And keep your head on a swivel. That's just one of those safety things that we talk about every day within our group. Quality control. So there's some things you can do up front, right, to help manage your expectations and to figure out if you're utilizing the right tool at the right time, right place. That starts with a mix design. All right, we definitely would recommend that for any job. The state of Iowa has actually gone away from doing mixed designs on cold-in-place recycling, but that's because they've been doing the process for 20 years. They've seen about every mixed design scenario you could see. Their staff knows how to really analyze some different testing parameters outside of mixed design to figure out which way to go with their project. Right? But if you're a newbie, that mixed design is a great tool. It's cheap insurance. We're always going to want to establish a rolling pattern where we have a nuclear density gauge out on every job. Right? Whenever conditions change, whenever your oil incorporation rate changes or your gradation changes, you're going to need to do another rolling pattern. Sometimes we might do a rolling pattern 3, 4, or 5 times a day as conditions change. You're going to want to compare your field gradations from your crusher to what you had in the lab, right, to just see if your surface area is equal. You're going to want to timely report any test results to the folks out in the field. Sometimes this is a struggle on projects, but that testing data that you as an owner might be collecting is very vital for us to make any adjustments that we might want to make. We want to know where we're at with things. Foaming characteristics. Like I said with foam, the amount of water you add and the temperature at which you heat the oil can really vary how well that oil foams or doesn't foam. All right, so you got to make sure that that's spot on. You got to monitor the moisture in the cold-in-place layer before you put a surface treatment on it. All right, so you're going to see a curing period of about 3 to 8 days. Sometimes you accelerate that by modifying some things. Sometimes it might take a little bit longer, but before you put a surface treatment, you got to get on it. You have to get all the moisture out of it. So that would be a limitation, right? You can't expect to do a night job, do cold-in-place recycling, and then put asphalt right on top of it the same night and then open back up to traffic. That's not going to work. It's a limitation of the process. So curing the cold mix mat, I talked about this a little bit, but really rolling traffic is our friend. Stop traffic is our enemy. All right, if you have stop traffic on a freshly placed cold mix mat, it's going to dimple within a second if it's not cured out. All right, so we want to keep rolling traffic on that mat. So if we're coming up to a stop sign, we generally like to see owners stop the process about 300 feet before we get to the stop sign, and then just mill and fill that last 300 feet, so you don't have a stopped car on that freshly placed mat. Frequent turning of a freshly placed mat can tear it. All right, you want to limit haul routes on a new cold mix mat. We do a lot of work in rural areas. Say this rural quarry hasn't been used for 6, 7 years, and a big state job starting up, 15 miles away, and all of a sudden we just see trucks coming in and out of that quarry at the same time we're doing the cold place process. We're going to get a failure. It's not, right? It's not going to work. Hot sunny days will accelerate the cure. We're trying to get the moisture out, right? So the hotter and sunnier it is, the better we're going to be. Water's out, you want to cover it up. So what type of surface treatments can you put on this? Well, it's anything, but you have to have something. All right, we have some folks that just go with a chip seal, some folks do a double chip seal. We did our first project with microsurface up in Chisago County in Minnesota here this year. Be really interested to see how that holds up. All indicators is that it's going really well. We put hot mix on top of this as well. So it really depends on your traffic count and the axle loading as to what type of surface treatment you want to put on top of it and your service life. So some other applications. We got out on the interstate for the first time 2 years ago in Iowa on I-680 around Council Bluffs. We did about 8.5 miles, and they put 4 inches of hot mix on top of it. Through the winter into the spring, it performed really well, so they had us do another 8.5 miles this season. And so the cold in place process is out in the interstate here in the Midwest, where folks said it couldn't live, but it is now, if you have the right conditions out there. We do a couple local airports every year. It's a pretty good application of the process. It's always then surfaced with hot mix, just because the loadings from a plane. I don't think a chip seal would live too long out there. We do cold in place recycling over concrete all the time. Do a lot of that work in Iowa. We just started doing it some in Minnesota here. Really successful at mitigating reflective cracks that come back through from that bottom layer. In urban and suburban areas with the different technologies, with the cold central plant and the single unit train, we can get there now. And then shoulders on the interstate, that's a great way to process material cheaply with a cold central plant, right, to redo your shoulders out there. Bring that shoulder material to a centralized location like the pork chop of a intersection with some off-ramps. Just dump all the wrap in there and then process it and bring it right back out. It's a great application. Rarely do the shoulders see a lot of traffic, so it's a really cheap alternative. So just to summarize, it's critical to utilize the right tool, the right time, the right place. All right? Know where the process works best and apply it there. All right? Don't go home and just wholesale start implementing this everywhere. But if you have a job where this won't work, give us a call or give someone from area a call and talk to them about what you could do then instead of this to help save you some money. We got a solution for you. You're going to save money. You're going to save money on roadway maintenance. You have a smoother ride, and you're actually going to reset the service life of your pavement system if you start implementing some of this technology. You're going to have shorter construction durations than you would versus a reconstruct. And then we're green. I'd say we're greener, right? That mill's still burning a boatload of diesel every day. I'm not going to lie to you about that, right? But we don't have trucks flying up all over the place, all right? It takes a lot of horsepower to process that material. With that, my contact information is up here. Feel free to get a hold of myself or anybody at Midstate anytime. I'd love to come talk to you about the process, your specifications, whatever else you have going on. And if anybody has any questions, I think we're probably up against it for time, but yeah.
Dan, you mentioned you see the trend toward more central plant in the future.
Yes.
What's the reason for that?
I think that the word's out, or the word's getting out. I think folks kind of shied away from it for a while just because they didn't really understand cold mix and where it was best utilized here in the Midwest. And I also think that there are contractors here locally that are willing to do it now as well. Before you'd have to bring someone from really outside the Midwestern area to do it. Previously, or now, there's folks here that want to do it.
It would seem that you're picking it up and hauling it to a central location and hauling it back out to the job and increase the cost of trucking related to it. That's the reason I asked.
That's another component, right? So you have to have the right tool, the right time, the right place, right? So that trucking cost is going to add to your ton price, but you have to truck hot mix regardless. Yeah. If you had a cold central plant set up at the same location as you did a hot mix plant, the cold mix is still going to be cheaper. We're using 100% recycled materials. We don't have to go open up a quarry to go mine that virgin aggregate and get a permit, which in Minnesota is brutal. I'm sure it is in other states as well, environmental permitting for mining, but that part of the process gets taken out.
You also mentioned there were some test sections down comparing one versus the other. Where are those located?
They just got placed about 3 weeks ago up at Min Road. So the National Road Research Alliance, I'm sure some of you are familiar with that group. They're going to be studying that material over the next 4 or 5 years. I think NCAT has some of that going on too. Maybe that's what Steve was pointing out. Yep. So they have a similar test going on down at NCAT.
Dan, up in northeast Iowa, where I do the design of 3R type projects, we'll add a paved shoulder, and then we'll cold in place recycle the full width of the paved structure so that water can drain transversely if it gets into that cold in place layer to either out to the granular shoulder with floor slope or whatever. I'm wondering if that's kind of a universal practice that you've seen, or do some people just maybe cold in place the main line and not touch the shoulders?
I'd say that's a best practice, what you guys are doing. So what they do in a pavement widening scenario is they'll actually pave the outside shoulder before we get there with the train, and we'll incorporate that new mix from the shoulder with the old weathered mix in the center lane. What that allows it to do is it allows water to escape out the side and doesn't create a bath. All right, and I would say it's a best practice. We have some people that do it the other way. All right, and we've had some experiences where the cold mix won't fail. It won't rot out. It'll be just fine, but we can't get the moisture down below 6%. All right, because you've created a bath. And you get 3-4 days where every 3-4 days just keeps raining. And that's one of those jobs where instead of being able to pave after 3 days, it might be a month. Right, so I would say it's a best practice.
The second question, you had mentioned you can change the cross slope 0.5%. Can you do that at the bottom of the cold in place?
Yep.
So you can get that range going out?
Yep, so we'll do it at the bottom of the cold in place. Yeah, so the mill will have an averaging ski on it as well. It's got full electronics, right? So we really have 2 attempts to improve the ride and that cross slope with that, right? One's with the mill and the second's with the paver.
You mentioned many, many times, you gotta get moisture out, gotta get moisture out. Now, if you're using the foaming process, that's not an issue, right?
But it's still an issue.
It still is an issue.
Yep, so we're adding water at the mill head, right, to cool the teeth. We're adding water in our crusher to keep dust down. That's a new OSHA standard they have out there now. And then we're adding water to the oil to make it foam.
Okay.
All right, and so that moisture, it's still going to be elevated, and that moisture will help you with compaction. It helps us get density, right? So we need to get that moisture out before it gets surfaced, if it's foam or if it's emulsion. I'd say this, foam's going to cure out faster than emulsion, though, right? Because there's less water in foam. Still needs time, though.
Is that a problem? Because sometimes it's set up on you before you get the grade out of the way ready?
No, not anymore. There was a time when some of the emulsifiers that are used in the engineered emulsion would take off prematurely. And we actually had mix set up in our pug mill or a windrow set up that we couldn't even get a pickup machine through. But that was years ago. And the industry's figured out what they need to do with that now, and we don't have that issue anymore.
So you're saying 3 to 4 inches is the sweet spot. What would be the thinnest you would?
We've gone as thin as 2 3/4 or 2 1/2 over concrete because that's all the mix that was there. But I wouldn't go any less than that. Then it's going to behave a lot more like hot mix, and the cracks are to come back a lot sooner. All right, thanks for your time, everybody.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.